In this video we will talk about the problem number 35. Spectroscopy can be used to identify chemical compounds and elements. It can be classified in 4 devices working together on determine an unknown compound. These devices are 1. UV spectroscopy, which is used to identify conjugated systems. 2. IR spectroscopy, which is used to identify functional groups. 3. Mass spectroscopy, which helps in finding the molecular weight and molecular formula. 4. NMR spectroscopy. These devices are good for finding the arrangement and number of carbons and hydrogens. Starting with IR spectrum, from the IR spectrum, there is no aliphatic groups. But there is an absorption of more than 3,000 which indicate the presence of an aromatic ring. And we can also note the absorption at 1662, and this indicate the presence of carbonyl group. Then we should find the index of hydrogen deficiency by analyzing the chemical formula. C14H10O2. 2 multiplied by 14 plus 2 equals 30. 30 minus 10 equals 20. 20 over 2 equals 10. So we have 10 double bonds, and this indicate the presence of 2 benzene rings and 2 carbonyl groups. Moving to HNMR, we find no peaks between 0 and 4, and this indicates the absence of aliphatic carbons. We note a doublet environment at 7 to 8 that indicate the presence of aromatic compounds, which are 2 benzene rings. Then we go to C13NMR. We find no peaks between 0 and 100, and this indicates the absence of aliphatic carbons. We also find signals between 120 and 160, which proves the presence of aromatic rings. We can also find a signals before 200, which proves the presence of the carbonyl. Finally, we go to THW mass spectrum. We find the molecular ion peak at 210, which indicates the molecular weight. The base peak at 105. 210 minus 105 equals 105. This proves that the molecule has been split in half. 105 refers to a benzene ring with a carbonyl group, and so, this is the final structure.